Просимо, будь ласка, включити запис. Okay, we are now continue our workshop, and now is session 2, second, yes. And we have the next presentation after Solena Glazunova and Yaroslav Ponzel, and the presentation or report for the team technologies and algorithms for the implementation of the recommendation system for creating an individual study plan for higher education students. Yaroslav, are you ready?
I'm ready. Thank you.
Okay, please start the presentation.
Okay, let me share my screen. And that's way. Please let me know if you see my presentation.
Yes, we see your presentation. Let's start.
Okay, thank you. Hello, dear guest. I want to present you our subject related to technologies and algorithms for the implementation of the recommendation system for creating an individual study plan for a higher education student. A long name, yeah, I know. Authors Olena Glazunova and Yaroslav Ponzel, and I will be presenter for today, Yaroslav Ponzel. As you already may heard, that we will have some changes in our education system in near future. So according to the draw law 10177 on the development of individual education trajectory and improvement of educational process in higher education, higher education students will be able to independently determine the format and trajectory of their studies. Students will have the opportunity to independently create the scope and timing of their studies, which will provide the opportunity for the students to individually build their learning trajectory by choosing the period of study of compulsory subject and subjects that they choose within the curriculum of their specialty. But trying to create individual study plan, students and university faces with a lot of problems. Let's identify the main problems that appears on the way to solving this problem. The first one is scalability. Scalability is the more students a university has, the more works it needs to create individual study plan. For this case, a higher education institution either needs to recruit a large staff to train, organize process and communication with the students, and constantly spend a financial resource on the work of this structure, or it needs to automate process and entrust it to a certain system. The second one problem is big data. It's problems that appears due to need to process a large amount of data to provide quality advice, to build an individualized plan for students. The third one is changing the calculation model. The problem appears when recommendation is creating study vector for students were built using one specific algorithm based on one data. And then there was a need to make the algorithm more accurate or expand its data cluster for processing. To make changes to the data processing algorithm in system where a significant amount of work is performed by human resource, this will cause confusion, errors, the need to rewrite existing schedules, training, to educate staff, etc. Accessibility, it's another one problem. It will not be very useful if the consultation of the subject of selection takes place only during working hours, in limited number of requests, and with intervention of negative factors of influence such illness, long distance between consult and consulting. And the human factor, the last one, it's factor that it's always present in system where there's human influence, and greater this fluence, the greater the risk of error. Taking in account the above-mentioned problems, we can conclude that the implementation of an automated system is the most priority way to provide personalized recommendation for students in building their curriculum. Therefore, the goal we set for ourselves is to identify technologies and develop algorithms that can be used to implement the basic logic of recommendation system that will be able to solve the problem of forming individual education plans based on processing large amount data. During our research, we tried to create basic algorithm to resolve about mentioned problem and to start work for our large education recommendation system. We using matrix factorization and methods for evaluating the accuracy of the assessment. The basic logic of the recommendation system was built in C# programming language and using Microsoft ML library.
I'm sorry,
We are using...
one second,
Yeah.
please. Sana Zazimko, please turn off your microphone.
Okay.
Thank you.
Thank you. Why we are using matrix factorization? Because it has both advantages, such as the ability to provide a personalized forecast based on the interaction between user and products. In our case, it's subjects, and the ability to work with different types of data. But also this matrix factorization has disadvantages, such as mandatory need for large amount of data to provide an accurate forecast and complexity of computation. This set of advantages and disadvantages is satisfactory for our task because we already had a lot of data for our predictions. So that's why matrix factorization suitable for us. Yes. In our article, we present to you a detailed way how we build our algorithm, and there are a lot of explanation of algorithm structure. So here, I only want to describe the main parts of algorithms. For example, the first one, it's a model for data. We created a lot of model for data for good working algorithm. This model, it's like student education info, student score, subjects. In our article, you could only see the piece of code for this part of logic. Also, we need model to machine learning train and for prediction result. The third one, we need some service with endpoint if we want to have access to this code from different places. For example, we want to build a large system, and we only in one case wanna give for students these prediction results. So we just trying to connect with this endpoint and give some results by student ID. Also, we need some working repositories that could give us access to live data of education info and scores, and some mathematical formulas to evaluate the accuracy and train our machine learning model. It's our primary goal, and mechanism for providing a recommendation of some count top object for learning. The main algorithm will have the following approximate form. As you can see, the base of our algorithm data, it's grades of subjects of student of the same specialty for the last 3 years, because 5 or 10 years it will be not very useful and not very fair enough. The similarity of subjects, we wanna give advice students to to learn some similar subjects that already passed by student, and grades of our target student for the period of study. In this case, we will know what kind of subjects students was passed on, I don't know, 19 degrees and higher. And now I want to present the work of our algorithm. Please tell me, do you see now our site, Google Chrome page?
No, we see your
No?
presentation. Share please your
Okay.
screen now.
Yeah, I will reshare.
Mhm.
1 second. Yeah. Here and share. Here you can see
Yes.
some real example how our system works. It is the real student with some educational info. I muted some confidential personal information. You could see that it is student of Faculty of Plant Protection, Biotechnologies and Ecologies with some degrees, and we could go to selection of disciplines, and we could see that we already have selected some disciplines, and we could select another one, refresh our systems, and we will give another two subject that our system recommend for us. And also, for example, I could share another one example. This another one student with another one degrees. The student passed only 1 year of education because the previous one was passed already 3 years of education. And this is student of Educational and Scientific Institute of Forestry and Horticulture. And we can go to selection of discipline, and we could see that our machine learning system give another one subjects to educational. So our system work specific for different type of students and could give advice for different student in different cases depending of his scores, etc. And let me finish my presentation. Yes, here's one. Yes, and conclusion. We built some basic algorithm for our system that give us ability to start work for give some recommendation for student based on their previous education scores of education scores of students of similar speciality, etc. We define some basic data for this training model, and we defined our future way. And we trying to define some appropriate programming language and appropriate programming library for this education system. So in this case, it was very useful to implement this work in C# and together with ML.NET machine learning library. That's all. Thank you.
Okay, yes, thank
Yes,
you
that's
for
all.
your report. And now we have questions. First is Alla Prokopenko, please.
Thank you so much, Yaroslav, for your interesting report. And I have a question.
Yes.
question number 1. So, what are the main algorithms used in recommender system to create individual learning plans, and what are their advantages and disadvantages?
Oh, okay. As I already mentioned, we used matrix factorization. The main advantages is ability to provide a personalized forecast based of interaction between user and products, because we of course have this interaction when students already passed some disciplines, some subjects, and already he got some scores of these disciplines. That's why in this case our systems, of course, has disadvantages, because our system can give some forecast for future subjects only in a case when our student passed, for example, half year of education. If it's only freshmen, only students from first years of education, our system cannot give some advice of future disciplines, because we haven't a lot of data for accurate forecast.
Thank you so much.
Thank you. And we
Yes,
have
thank you.
another question, Dmitro Antonyuk.
Hello, thank you, Yaroslav, for your interesting work. So I have several questions. So am I right that the main criterion for your system is if the person will be successful in completion the class?
Yeah, we base it on this factor, because we think that if student will have higher education score of this discipline in future, then this discipline will be more suitable for this student. In the future, it's base algorithm. In the future, we will add some detail, some additional factors, maybe different ways to build this prediction. Maybe our students wanna build prediction on, for example, one way, on Saturday way. So in the future we wanna make this algorithm larger and complexity.
Okay,
Yeah.
so here maybe some input, because, for example, one of the scientific school of Stanford is busy with researching, choosing the educational passes, and especially not obligatory passes, but additional passes. And they define two main criterions for students to choose these courses. It's either students might be how successful might be students in completion of these courses, or students really want to try additional areas, maybe to choose their future minors or something. In that case, it's difficult to tell about very successful completion, but it gives another advantages to the student to be able to try something. And this is especially important during the first courses, where a student may try and make decision either to continue their advancement in the area. So maybe you could also think about trying this approach. Maybe within algorithms you are using, maybe you kind of, if you think about reinforcement learning, so maybe you do a bit less of exploitation of present knowledge and a bit less of discovery of potential advantage for the students to try something new. Also, it will maybe lead to a bit lower grades for the class. So it might be also part of your future discovery for this work. Thank you.
Yes, thank you for your advice. As I already mentioned, it's base algorithm. In the future, we will add some feature for this algorithm. And thank you for your advice. We will think about it and maybe set this advice to high priority for implementation. Thank you.
Because also, additionally, ML.NET library contains at least several reinforcement learning algorithms where you can maybe try an experiment to add to your system.
Yeah, we wanna do it. Yeah. Thank you.
Thank you for interesting report. And now we go to the next presentation. The next presentation is visual modeling technologies in the mathematical training of engineering in modern conditions of digital transformation of approach to creating visual content. Tana Kluchko, are you ready?
Yes, I'm ready. Dear colleagues, dear conference organizers, I'm presented our research, video research.
Please share your screen.
Yes, I'm sharing screen. Thank you. It's okay?
No, we see. Yes.
Yeah.
Dear colleagues, dear conference organizers, thank you for the opportunity to present the report. Dear colleagues, bring to your attention report on the topic visual modeling technologies in the mathematical training of engineers in modern conditions of digital transformation approaches to creating visual content. The authors of the study are Vitaly Kluchko, Oksana Kluchko, Vasil Fedorov. One of the main applications of digital tools as innovative technologies and tools is modern engineering education, which requires advanced tools to ensure a high level of specialist training. Using artificial intelligence, immersive technologies, simulation platforms, specialized information system, and various interactive software tools enables students to better understand complex engineering concepts and apply them in practice. Increasing the level of mathematical education of future engineers is an important component of their quality training. In the teaching of mathematics, digital technologies play an important role, in particular through the creation of visual content, such as graphic images, in particular interactive and dynamic graphics, virtual models, and animation, visualized tasks, virtual laboratories, etc. This enables teachers to effectively explain abstract concepts and creates conditions for students to gain a deeper understanding of mathematical ideas. So, the purpose of this research is the development of visual modeling technologies in the mathematical training of engineers in modern conditions of digital transformation of approaches to creating visual content. We can highlight the following main areas: cluster of mathematical modeling, educational cluster, cluster of intellectual analysis and machine learning, cluster of information processes and systems. A semantic cluster analysis of modern research by a scientist was carried out using the WOS-viewer system based on data from the Scopus Symptometry database. Please see figure this slide. A search using the keywords visualization and engineering and learning and mathematics found 130 scientific papers published during 2019 and 2024. The task of the research is to determine the main components of the visual modeling technology according to formulation of the research problem and presentation of the description of the research object. Formation of basic educational building a model of images of learning objects, improving the quality of training students in mathematics. The essence of person's visual spatial cognitive nature is his ability to master three-dimensional space, starting from elementary spatial perception and orientation, develop spatial thinking, within specialists of engineering specialties, and integrates with other formats of intellectual activity, analytical, synthetic, creative, analytical, mathematical, technological, etc. Along with the need for mental mastery of space by the future engineer, the necessary factor of the formation of his professional competence is mathematical thinking and at criterion level mastery of mathematical as a tool of professional activity. Accordingly, it is expedient in the process of mathematical training of engineer to actualize the applied aspects, which is aimed at forming the professional thinking of a future specialized with expressive, spatial, and mathematical, analytical, synthetic components. Based on integrative application of phenomenological, structural, functional, and hermeneutic approaches of the visualization approach, distinguish the following main formats of visual modeling: visual spatial representation, visual spatial illustration, visual spatial clarification, visual spatial metaphorization, visual spatial interpretation, visual spatial algorithms, and schemes. The use of schemes and models of didactic objects and concepts in the process of mathematical training of students of engineering and technical specialties shows that the use of different types of visualization is expedient. For example, using the capabilities of modern digital technologies, their capabilities to operate with mathematical analogs, in particular, cloud platforms, artificial intelligence systems, programming languages with appropriate libraries, such as Python or JavaScript, etc. For example, if you have the vector field using the chatbot based on artificial intelligence ChatGPT, you will get a detailed explanation of how the 2D and 3D vector field function looks like, as well as a description of the steps of building 2D and 3D vector fields with the corresponding implemented algorithms in the Python programming language. As a result of the execution of these programmed codes, we will get the images presented in the figure A and B. For the development of mathematical graphic content with various tools, for example, by the Matplotlib library in the Python programming language, the figure shows different options for graphs built using the Matplotlib library in the Python. The technology of visual modeling during the study of the course of advanced mathematics and technical institution of higher education will be presented in the following schema. Please see figure. Statement of the problem formulation of project task. Formation of the model and determination of its numerical and attributive characteristics. Building a mathematical model. Determination of the described characteristics. Determination of relationship between the source characteristics. Formation of the goal of the modeling process. Construction of the formalized model. Development of the interactive component of the model. Construction of the symbolic model. Let's consider an example of modeling the process of mechanical processing of parts of means of differential equations. The task of dynamic modeling of the process of surface plastic deformation of a part with a fixed hydraulic damper in the center during mechanical processing is under consideration. See figure. The mathematical model of a differential equation that describes the process of surface plastic deformation of the part fixed in the center with the beating of B has the form. So far, it's not possible of obtaining the solution of the equation in an analytical form. Therefore, students were familiarized with the corresponding function of the numerical solution of system differential equations and the construction of graphs of solution in the math environment. With the help of computer mathematics systems, dynamic processes are visualized. To a certain extent, it can be acquired that with the help of constructed graphs, the solution of differential equations can be approximately determined using various approaches. The analysis of the obtained approximately solutions allows to determine parameters of the investigated process. If you create a series of graphic drawings, they can be animated. With the help of appropriate commands in computer mathematics systems, you can change the direction of the object's movement, speed it up or slow it down, or pause it. According to the set goal and hypothesis of the research, the pedagogical experiment was carried out with the students of engineering and technical specialists. In the experimental group, training was conducted using modern systems of computer mathematics and visualization of mathematical objects, in particular interactive visualization and virtual laboratories. Traditional classes were held in the control group. The effectiveness training was determined using the developed criteria of the levels of formation of mathematical visual modeling skills among students in the process of studying the advanced mathematics course. Figures shows the difference in the distribution of points in the groups. After the formative stage of the experiment, the number of students in the experimental group who had a high level of knowledge and skills in information technologies increased by 14.3%, while in the control groups it decreased by 1%. The increase in the number of students in the experimental groups with a medium level of formation of mathematical visual modeling skills is 15.1%, and in the control group 4.8%. The decrease in the number of students who won the formation of knowledge and skills at the low level in the experimental groups is 27.1%, and in the control groups 5.6%. Thus, the result of the statistical process provided a basis for the conclusion that the use of the proposed technology led to an improvement in the results of learning advanced mathematics. The results of the formative stage of the experiment shows that the purposeful use of visual modeling and the means of its implementation in the process of learning the advanced mathematics course has a positive effect of the process of forming students' mathematical and educational and research skills. The application of the proposed components of the advanced mathematics course technology contributes to the formation of students' abilities and skills in the use of modern mathematical point visualization system, which is in the desire to adapt to the rapidly changing information environment of activity, increases in the particular significance of the results of mathematics education. During the experimental research based on the analysis of the characteristics and results of the students' training, it is possible to draw a conclusion about positive professional orientation changes in the cognitive need, motivation, emotional, volitional, and behavioral sphere of the respondents. For example, increased interest and motivation for learning, actualization of ability to problematize and its visual representation, cognitive skills to quickly find inconsistencies and errors and effectively correct them, integrative application of mathematical and spatial thinking as the tools of professional activity, the ability to arbitrarily concentrate attention on the subject of study for a long time, emotional domination and balances, and actualization of emotional intelligence and enthusiasm for activities is also observed. We have developed practically oriented recommendations aimed at the effective implementation of visualization technologies in the practice of teaching mathematics for specialists in engineering specialties. For example, selection of visualization format, selection of software tools, professional and educational motivation, creative focus, harmonizing of emotional and development of emotional intelligence, application of the scientific principle and didactic approaches, actualization of innovative potential. According to the results of theoretical and empirical research, the following conditions were determined and factors of visual content design: individual features of information perception by students, types of perception of visual information, the specific of the advanced mathematics course. visual familiarization with mathematical concepts and visual perception of their properties, connections, and relationships between them allow students to quickly and visually unfold individual fragments of the theory, form and spread and generalized algorithms of operation, apply the acquired knowledge and skills to learning the content of other sections of the advanced mathematics course and fields of knowledge. Generate mathematically expected results that can be predicted using visual models can also facilitate the process of prediction of possible outcomes, identifying non-standard situations, and undefined directions for overcoming them. The formation of visual modeling skills are one of the components of modern mathematical training of engineers, and their research skills is effective in teaching advanced mathematics. In the research process, several components were developed technologies for the formation of visual mathematical content. The dynamism and interactive of built visual objects made in mathematical content visualization environment, such as MathCAD, in the process of studying the advanced mathematics course allows students to effectively form knowledge, skills, and abilities on the relevant topic, promotion in the mastery of various problem-solving methods. The results of the formative experiment show that the purposeful use of visualized modeling and the means of its implementation with the help of computer mathematics system in the process of teaching and advanced mathematics course has a positive effect of the process of forming students' mathematical and education and research skills. The application of the robust components of visual modeling technologies in the course of advanced mathematics contributes to the formation of students' abilities and skills in the use of modern digital technologies, abilities, and the desire to adapt to the rapidly changing information environment of activity, and also increases the practical significance of the results of mathematics education. Dear colleagues, the report is over. Thank you for your attention.
Thank you for interesting report, and now we invite everyone to the questions. Who have a question? Alla Prokopenko, please.
Thank you, Oksana, for interesting report and very important research. And I have a question. What specific visual modeling technologies are used in the mathematical training of engineers?
Thank you very much for your question, Diala, and thank you for interest for our research. We have a different models. This model is graphs. This model is visual representation and visual content. And another research we have with lectures, mathematical lectures, advanced mathematical lectures, we have discussed about use the artificial intelligence model and artificial intelligence, no original model, it's graphic, video, and maybe programming language text. For example, we use the programming language Python text and visualization. Very good answer for question how it's visualized. For example, difficult mathematic analogs is very good answer is with ChatGPT we have very good, but now we have discussed with the lectures, and I think maybe this our future because we need adapt for artificial intelligence system. Thank you very much for your question.
Thank you.
We have a question in the chat. How does digital transformation affect approach to creating visual content in engineering education? It's a question from Olga Pinchuk. Thank you.
Thank you very much, dear Olga. Thank you very much for your question and interest for our research. Yes, we have a different effect about include this technology in the education process. For example, increased interest and motivation for learning. For engineers, it's very good motivation because have programming code, we have code, we used different platform, ASCAT, for example, and it's very good for engineer in this stage. In this stage, develop digital technologies, and for example, actualizing of the ability, problemize, and its visual representation, cognitive skills, and quickly find inconscious tense and errors, and this effectively correct them. Integrative application of mathematical and spatial thinking and tools professional activity, and very good effect, I think, is the ability to arbitrarily concentrate attention in the subject of study for a long time, emotional harmonizing and balance, actualization of emotional intelligence, and enthusiasm for activities it also observed in your professional. Thank you very much for your question.
Okay, thank you. Have anyone questions for the speaker? Okay, if no questions, we come to the next presentation. The next report is a report for the team Intelligent Parametric Educational Web Platform System Design. Authors Volodymyr Nazarenko, Oksana Zazimko, Larisa Klich. Volodymyr Nazarenko, are you ready?
Yeah.
Okay, share your screen, please.
Good day, everyone. Can you see my screen?
Yes.
Greetings again, everyone. I would like to present you a report on Intelligent Parametric Educational Platform System. Nowadays, of course, educational technologies is widely spread and widely used by teachers in high schools, in universities, in colleges, in online classes everywhere. Of course, nowadays there's like a lot of different like content, like text, video, content, different like platforms for online courses. At the same time, technology overall is growing and developing rapidly. And of course, this advancement in artificial intelligence, in web tools, in software development tools, in new like design paradigm are being implemented in various areas and fields of application. And of course, education is one of them. There's a lot of, let's say, possibilities here to use and implement different materials, different like content. Of course, the simplest of them being is, of course, just using existing technologies and platforms like ChatGPT, which people talking about like different online education platforms like Google Classroom, Moodle, Canvas, using different tools for generating content, video, text, and audio, like DALL-E, Firefly. Of course, with different like circumstances, like viruses, conflicts, and cataclysm, the educational process is moving more towards remote, or at least hybrid systems. So teachers and classes have been using different communication services for remote communication, like Zoom, WebEx, and many more. But of course, all of these tool sets are just tool sets. But the main goal of education is share knowledge, teach, and of course, like do assessment, do practical classes, and this should be done in special environment, both offline and offline. So for hybrid environments, of course, we've been using different massive online open courses platforms, or just different combination of tool sets. So we want to focus attention that is much more convenient to use one larger platform with different like subsystems and plugins for teaching rather than combination of many tools, because tool sets are just tool sets and the platform itself is, as you say, educational playground. For this specific course research, we focused on several different courses that we have been teaching. Mostly it's STEM, of course, classes, but the results which provide also can be applied to humanitarian classes, also to like not only higher education, but different like other stages of education, because this platform itself doesn't like focus on one specific class or one specific like area and field of study. What is important, of course, for any educational process is individual course material and course pages for teachers and students, assessment system, because we want to teach students, like people and children, to get skills or to use this knowledge in practice. Of course, assessment or different forms of assessing, practical assignments is very important for this. Of course, there's like existing tool sets like Moodle platform that consists of different like already available tool sets and platform, and it provided its own field for assessing. However, for future, we would like the platforms that we are designing, it should be extension of this available platform with focus on broader area of study, not just provide the tool set for just uploading text, checking text during lecture, but more for the process itself, with more active interaction between student and teachers, to add gamification system, into real-time feedback system, like chatbot to answer like student question when there's like teacher is not available and different like offline and classes are not available. So there's like different issues with getting access to the course specifically. So of course, the idea of this like new platform not only focuses on tool set to create a course, but also for active learning process, and not only for teachers, but also for students, not just to upload content, but use this platform to teach, to practice. And of course, with this like AI tool set and API architecture is convenient to implement and use. This platform itself is part of larger frameworks that we're conceptually and developing right now. It consists of different like modules. There's like knowledge-based module, there is content-based module. But more importantly, all of the systems are focused on data, because we already have content, we have materials, but this tool set should help teacher and provide good information. And also it's very important to include into this like system users, not just teachers and students, but also other stakeholders and people who are like make decision in university. And teaching is like including not just professor, but teaching assistant, deans, department heads, and other people. Of course, their availability and access to the system should be limited, but at the same time, they should be, also maybe some information should be available public. So the platform itself is divided, have two focus. One is like lecturer and student specific like plugins, or you can call it sections. But at the same time, this is like more for interaction. But apart from interaction, there should be content. So for this comes like course page, where like a place for actual interaction and teaching and sharing knowledge. And for assisting in this interaction, there's like a smart feedback system. Should help with data management, with like all technical aspects of this platform. Because of course, teachers and even students, they probably not all of them are tech savvy or like software developers or IT engineers. So of course, they don't need to know the tool set. It shouldn't take them quite a while to set up this platform. So this like smart system should be automated, at least semi-automated, to help students and teachers set up courses, create content. So of course, like first stage would be at least like manual setup, but second would be semi-automated, and like final iteration version should be completely automated. So meaning the teacher and student just set up information, they set up platform, upload courses, everything that's needed, but like knowledge-based system, the course application itself should load and set up automatically. So of course, for the beginning, like what is also very important for this platform is real-time communication, because what systems have nowadays, apart from some cases where they have at least maybe some automatic assessment or automatic test checks, most of this is done like not in real time, but needs to be set up and need to be like, for instance, there's a question or message needs to be processed by teacher, by student, set up. But for the future, it should be more like real time and automated, when you don't need to wait for teacher to reply or get a content or answer your question or provide an assessment. So that is where this platform comes into place. And of course, this platform itself that we're providing comes from two ways. One of them is more technical, like aspect is like a platform itself that needs to be set up to existing like massive online courses platform that people have been using, but also from UI perspective of and UX from like interaction perspective for how the students and teacher will be interacting with this web platform, how will be they setting up. So that is like part of what we are doing and will be doing in the future. And of course, like adding integration of AI tool set, like for text generation, for processing, for visual content, and everything. And of course, also one important thing not to forget is gamification, because nowadays when everything is moving much faster, when the process of education is much faster and more dynamic, so of course adding like gamification aspect is quite important and vital. Like there's a lot of like small like educational courses or like application be doing that, but on large scale it still needs to be implemented and presented. Yeah. So thank you for attention. That's all from my side.
Thank you for your report. It's interesting. Who has the questions for these authors? Okay, if we have no question, I have a question. What key technologies and algorithms are used to ensure adaptability and personalization of the educational process on an intelligent parametric educational web platform? Thank you.
Thank you for the question. For parametric, we've been using like, well, as I mentioned, this article is extension of several other papers. So like our research in other paper focus more on data and algorithms. So for that, there's like a specific knowledge base. For parameters, if not mistaken, there's like important specifically for course evaluation and assessment. Algorithms, what else? Which is mostly about, of course, how like evaluation happens if test, if there's like a text-based, interaction-based, if it's like visual, if it's quiz. What else? Of course, there's like different, like what I plan to introduce is more automatic, how to say, checkup and evaluation when it's not just in points, but more in terms of completion, because each student has their own knowledge. So that is been trying to get the algorithm for actually evaluate like individual students themselves on their own performance, rather than make a universal platform so everybody is the same. So, but it's like specifically on data.
Okay, thank you. And we have one question in the chat from Olga Pinchuk. How can the implementation of an intelligent parametric educational web platform affect the effectiveness of learning and interaction between students and teachers? Thank you.
Well, the goal, like long-term goal that we aim with this is to make it more interaction seamless. So it's not just like class that you sit from 10 to 11 a.m. and that's it, and it like ends there. So it's more like to have access to courses, or at least to answer a question or to get feedback, or be available to even like personally progress faster, a bit slower in real time. So with this like platform, it should be not tied to a specific schedule or like specific setup, rather for like individual, moving towards more individual learning plans and individual like performance. So with this, it should be more effective for individual students. For teachers, the platform itself should be more convenient when, for instance, they don't just like upload content, but they create a platform, so that a bit even without like technical knowledge. With more information, they just video lecture or content. Also use the information also from internet, because there's a lot of different resources, but this needs time to set up, this needs tools to set up. So for teachers, it should help with setting up all this information. For students, it should help in individual education and learning plan, and especially like in real time with modification in real time if it's needed, like to adjust learning paths or educational process.
Okay, thank you. Maybe someone want to ask the questions? Okay, if we no questions, let's go on the next presentation. And next author is Olena Anishchenko, Yulia Rogushina, Anatoly Gladun, and Sergei Prima, and his report, Semantic Analysis of Learning Objects, Thesaurus Approach for Digital Transformation of Educational Resources. Are you ready?
Yes.
Okay, please share the screen.
Так, share screen. Do you see my slides?
Yes, we are seeing slides.
Yeah, that's it. I start. Dear colleagues, the title of this report is Semantic Analysis of Learning Objects, Thesaurus Approach for Digital Transformation of Educational Resources. This work is represented by a group of researchers from different research and educational organizations, and now I try to speak about our goals in this work and their main results. Digital transformation of learning is a complex problem. Therefore, in this work, we consider only one its aspect that deals with semantic analysis of learning resources. We consider the schemas of metadata representation that are used for describing of learning objects, universal ones, and specialized for learning objects. Specific situations and groups of students that require expand the set of unified properties of learning objects. Use of external knowledge about learning domain and educational process that can be included into these metadata. Transformation of natural language description of learning course into formalized course thesaurus. Use of these course thesaurus for search of learning objects into the web with the help of semantic retrieval systems. And the last, development of local repositories of learning objects based on semantic wiki technologies that support processing of external set of characteristics of learning objects. This research is aimed on the digital transformation of learning activities based on use of semantic technologies and knowledge management models that support analysis, structuring, and retrieval of educational content. All proposed elements are based on ontological representation of knowledge that facilitate interaction between educators, students, and learning content. Proposed approach can be used for such learning domains. New disciplines, where high-quality textbooks are not developed. Dynamic spheres that need in actual updates, for example, technical sphere of programming and many others, and personified retraining of students with heterogeneous experience and competencies, for example, adult training that used individual sets of learning objects. Preconditions of this study are large number of open access learning objects with different levels of modularity, granularity, and forms of representation. Different metadata schemas used for descriptions of learning objects into different repositories. And a lot of information objects into the web that are represented without any meta descriptions of their semantics and structure. And the last, rigid metadata schemas of repositories that cannot be changed by users. Openness of learning objects is an important factor of their reuse and digital transformation of other educational elements, and such transformation of learning objects repositories into integrated environment can be based on the semantic web technology. Meta descriptions of learning objects processed by services of repository have to contain sufficient information for generation recommendations about their use in some learning courses in general and in personal learning trajectories of particular students that learn this course. Generation of recommendations can be partially automated if we have such metadata. The task of services of repository is to create semantically defined links between learning objects and other information objects such as courses, ontologies, competencies, and results of learning, and subjects, students, teachers, experts, developers of information support, and other elements of learning process. Problems of existing approaches used for search of learning objects. It is rather difficult for educators and for maybe for all people to understand specifics of available meta descriptions that differ in some details that define properties and meanings of digital objects. Most repositories of learning objects do not involve adding new parameters of learning objects in accordance with the semantics of learning domain or specifics of student, that users cannot do it themselves. Repositories are focused on the work with large communities and educational institutions rather than on individual work or collaboration of small groups with similar interests. Additional properties that are not represented usually in repositories can be divided into several categories. Properties related to the specific perception of learning materials by individual students or groups of students, maybe with some problems of health or situations, etc. Second, properties characterized by the technical features of learning objects and access to them. It is actual for blackouts, for example. Properties that define specific elements of educational content that can cause ambitious reactions of people from different cultures communities. And fourth, properties related to the specifics of the use of learning results and the possibility of creating more specialized modifications of learning course. These additional properties and knowledge about learning domain can make search of learning objects more efficient. In this research, we demonstrate the possibilities of semantic search of learning objects on example of MAIP's search system that allows users to specify explicitly the model of their information needs at different levels of understanding. MAIPS uses the semantic web technologies, in particular the overall ontology representation language. In general, this system has a Ukrainian interface, but some elements we translate in English. MAIPS uses the search learning objects, has to define ontology of learning domain, course thesaurus with positive and negative bases of elements, and type of learning objects, and keywords for current information needs of user. If user can define in general the domain ontology, then he or she can change course thesaurus or add some specific elements, and in some current work, they can use such keywords that are interested in them in some moment. Retrieved information objects are transformed into learning objects by adding of metadata values in terms of course thesaurus and standards of learning object metadata, and can be stored in local repositories of learning objects on base of semantic wiki technology. Semantic properties of learning objects can be described with use of wiki templates. An example of such a local repository is ActiveBook that we develop on base on semantic media wiki that contains the set of templates for typical learning objects such as textbook, learning course, video, etc., and other elements of learning process such as competencies or disciplines that can be used by educator. MAIPS and ActiveBook use ontology-based knowledge representation of the main elements of learning process ecosystem that helps in their integration according to user needs with other systems and services of learning management and advisory that are based on the semantic web technologies. Stages of development of such a local repository of learning object. User have to select metadata schema that describes structure of learning objects and their relations with other objects contained into the repository. Then define the additional properties of such learning objects are required, determine the types, semantics, and possible values of such properties. Next stage, import relevant learning objects from external repositories or from the web. And at last, convert or create the metadata of imported learning object according to the schema of this repository, automatically or manually dependent on the semantic similarity between them. This slide shows relations between ActiveBook, local repository tool, that is developed as a part of system Andromedia, that was developed as a tool for Andragogia, and other external resources and services of learning process ecosystem. As you see, it can be integrated with Advisont, with Wikipedia, with various repositories of documents, with MOOCs, with domain libraries, with external ontologies such as ESCA ontology of competencies, with other repositories of ontologies. And this system can propose some internal services that can be used to integrate knowledge from different resources and use learning objects in some process of learning more efficiently. And at last, conclusion. The use of semantic technologies is a necessary condition for digital transformation of education and development of applications aimed at learning management. Such semantic technologies provide processing and analysis of knowledge, support intelligent retrieval of digital educational materials, and defining semantic links between learning objects, selected according to the personalized characteristics and skills of students. Each pertinent digital information object can be transformed into a learning object manually or with analytical services by means of metadata related to a particular learning course with use of external knowledge bases. Semantic retrieval system MAIPS allows to process not only keywords and formal characteristics of retrieved information objects, but also to use a thesaurus of the learning course that describes the search domain. Metadata standards of learning objects play an important role in ensuring the efficiency of the creation, distribution, and management of digital learning content of different platforms and systems. They provide structured indexing of information, improve exchange and reuse of educational materials, promote cooperation between educational organizations and communities. But personification of learning process, such as personified learning trajectory construction, required additional parameters of learning objects that educators can use for search and fix into their local repositories of digital educational resources. That's all.
Okay, we thank you for your interesting report, and we have 2 questions. One, Alla Prokopenko, please.
Thanks. I have a question to Julia. What are the main advantages of using the thesaurus approach for semantic analysis of educational object in the context of digital transformation and education? Thank you.
Semantic search can make the search more efficient and more quick, because if we have to make it manually, we have to enter many additional information in all requests. But if some educator has a more stable sphere of interests, you can make these stable requests and only transform them in some way when you have some other interests. It's main economy of time and understanding.
Thanks.
Okay, thank you. And we have a second question from Dmitro Antoniuk. Dmitro, please.
Thank you, Yulia, for your presentation. I have a question. So in your presentation, I see you are studying like technical possibility and let's say theoretical and technical approach for reusing learning objects. But there are always another part, let's say organizational approach and economical part of that. So now in rather connected world, we see that reuse of content is not being done that much. And also even in big corporations and economically very stable establishments, we see that companies are trying to organize their own repositories, and usually they work with more or less data and learning objects within their internal libraries. So did you also study or pay attention to economical feasibility and organizational difficulty of actually using this approach of reusing learning objects based based on the theoretical and technical approach developed in your work?
Thank you for your question. Maybe we don't think about economic aspects of this model, but we think about reuse of learning objects by one educator or a similar group of educators. From the other point of view, we use semantic media wiki that is very popular for communication and collaborative work. Therefore, if we have such local repositories, then one educator can propose these materials with more semantically described learning object to other ones, and they have to form some learning trajectories from them if it's interesting for them and come into their group of interests.
Okay, so as I understood, you pay attention more to the work of one person or tightly connected group of people, so they are they more or less know each other, content of each other, and they have other reasons to collaborate and make content reasonable for reusing. So not for now, at least, not paying attention to the difficulty of collaboration in wider establishments and economic reasons to reuse it. So now it's for more tightly connected collaborative groups. Yes.
Maybe there's a lot of systems for collaboration of big groups and educational institutions, and we work with personified aspects that can be used for more specific situations of work that are not supported by general repositories or portals of educational resources.
Okay, clear. Thank you.
This is an additional tools, yes.
Okay, yes, thank you. Maybe someone want to ask questions more? Okay, if we have no questions, now we have a cover break, yes, and we come back at 1 p.m., yes, 13:00, and we continue our third sessions, yes. Now we finished this session. Thank you.
Thank you for your attention.
Thank you very much for the session, interesting session.
Все. Дякую всім. Гарного дня. Добре. До побачення.
Thank you for attention.